Hello, everyone. Welcome, everybody. All righty. Welcome, everybody, to our webinar today. Of course, the title of our webinar is Exploring the World of AI with the Dobot Magician Lite. The star of the show is the Dobot Magician Lite that we have right here. As you can see, he's currently outfitted with a gripper end effector. And we also have that little camera on the end of it that's going to help us to do some AI learning in the classroom. Without further ado, let me go ahead and introduce myself to those who don't know me. I'm going to go ahead and actually switch over to my slideshow here. There we go. And here we go. So, my name is Dr. Jake Rourke. I am the Curriculum and Outreach Specialist here with STEM Education Works, and I've spent a lot of time working with these little robotic pals here in the form of the Dobot Magician and the Dobot Magician Lite. Excellent robotic arms for learning, especially coding in the classroom. And today, of course, we're going to be incorporating a little bit of AI into that mix. So just a little bit about me. I graduated with a Bachelor of Science in Physics and Astronomy from Purdue University in 2012, so boiler up. I graduated with my MA and PhD in Astrophysics from Kent State University in 2018. And then I joined the STEM Education Works team in January of 2021. So this January has been my 4-year anniversary, so it's been pretty exciting. As the Curriculum and Outreach Specialist. And while I was in grad school, I got to do a lot of really cool stuff. I got to study neutron stars, do scientific research and astrophysics and all that fun stuff. But what I really enjoyed the most during my time in grad school was interacting with students as a TA. I also got to run the planetarium at Kent State, so I got to have kids coming in on field trips and families coming in on the weekends. It was a really, really fun time. And I originally went to grad school to become a professor in physics, but then I realized that my real passion really was to stick more in the education, especially K through 12 education. So that's kind of how I found myself here at STEM Education Works. I also love to code, and these Dobots here are a great tool for teaching that. So here's a little kind of an overview of what we're going to be going over today. We're going to be talking about several different functions that the Dobot Magician Lite has in terms of its AI capabilities. First off is voice recognition. And then we're going to be diving into the real meat and cheese of the presentation, which is face recognition, picture recognition, shape recognition, color recognition, and text recognition. It's really hard to say the word recognition a bunch of times in a row, getting tongue-tied. So, first things first, the application that we're using to control the Dobots is going to be Dobot Lab. That's an online application, so there's no download necessary. And specifically, we're going to be working with the DobotBlock Lab. For those of you who aren't familiar with block coding, that's going to be the medium that we're working with today. Block coding is an excellent way for teaching, especially young learners, how to code. You can program the Dobot, both the Dobot Magician and the Dobot Magician Lite, with Python, but the problem is if you have students, especially in elementary school levels, let's say, if you have students who aren't very experienced with coding and with text-based coding, it can be a real difficult learning curve at the very beginning there. So block coding really simplifies things. It makes it's more based on visual learning. You don't have to worry about memorizing syntax. It's a much more intuitive way for young learners to jump into the world of coding. And so if you were doing this on your screen, and if you were wanting to use these special AI blocks in our block coding application here, we would click extend, and you can add the AI extension. And that's going to add a whole series of these new pink blocks there that are going to allow us to not only use the Dobot to manipulate objects in three-dimensional space, but also to incorporate some of those AI capabilities using the camera that comes with the Dobot Magician Lite. So first off, voice recognition. I'm just going to try to show you guys the general example of how this works. We're going to save the actual really cool juicy parts like picture recognition and shape recognition and color recognition. We're going to actually do that live, but here I'm just going to kind of show you what the code would look like in order to incorporate things like voice recognition and image recognition into your programming with the Dobot. So right off the bat, here's a good example of some code that incorporates the use of voice recognition. Again, voice recognition is cool, but a lot of devices have voice recognition nowadays, which is why I said the real meat and cheese of this presentation comes in the form of the image recognition. But if you did want to use that in the context of DobotBlock Lab, you could set up a program like this. And in order to really break this down, let's actually break this into individual little chunks to understand what exactly is going on here. And we'll use this same approach with all of the code that we're going to be looking at today. So first, step one, we want to clear the speech recognition results and status variables. So we're creating some variables so that we can see, so we can get some output from our program to see if things are working successfully. So that is going to be those first two blocks up there. We're just taking those variables and we're just giving them blanks right there. So I just have like 3 dashes. So we're just going to clear it out, make it get rid of any memory of past values of that variable it has had. Then we are going to initialize the voice recognition capability of the Dobot and record for 3 seconds. And that, of course, is that pink block right there. Next, we are going to set the speech recognition results variable, and we're going to set that equal to whatever text was recorded by our Dobot. And lastly, we would have a certain output, like if the speech recognition results, if it contains the word milk. So again, we're taking that speech recognition results variable, we're assigning the speech recognition results to that variable, and if it contains the word milk, then we would say yes or no. And so that's a very simple version of the voice recognition. Next, we're going to jump into some image recognition. And this is the really cool part. So, for instance, if we wanted to go ahead and calibrate our Dobot, so right here I have an example of a picture of my face and a picture of a friend of mine. And what you can do is you can confirm that it sees you and it recognizes your face over someone else's. So what I'm going to do is I'm going to show you guys this code real quick, and then I'm actually going to replicate it for you all. So let's go through that same process that we did with voice recognition, but in this case for facial recognition. So first off, the only variable that we're using in this very simple program here is face. We're going to clear its value. The next thing we're going to do is we're going to initialize the camera that's on the end of our Dobot, and we're going to have it take a picture after 3 seconds. Next, what we're going to do is we're going to set the variable face equal to that image that we got, and we're actually going to associate it with the tag associated with that image. And I'll show you guys that here real soon. And then lastly, if the face variable contains the word Jake, then we're going to make the program say, hello, Jake. And if not, we're going to make our program say, who are you? Because, you know, I'm technically the owner of this Dobot and he recognizes me. So, you know, I want to make sure that he recognizes the person he's working with most of the time. And so what I'm going to do real quick is I'm going to share my screen here. I'm going to switch over to Dobot Lab. There we go. Are you able to see Dobot Lab on there? Awesome. Cool. So first things first, you'll be able to see in the little stage area right here, this wood piece is going to be what we're going to be using later for placing items down so that to test if the Dobot can differentiate between them. But real quick, I'm going to go ahead and I'm going to tell Dobot to say hello. So Dobot, just give a little bow. Thank you. Thank you, Dobot. Always got to, you know, my Dobot's very, likes to show off. So anyway, so that's my program there. Then what I'm going to do is I'm going to go ahead and open up my file called face recognition. And so it's going to take a second to load. And so over here, you can select between the Magician Lite. I'm going to go ahead and make sure that I have Magician Lite selected. I'm going to go ahead and connect my Magician Lite, and it is homed, and we're good to go. But to show you what it looks like to set up the data that this needs to work, I'll go ahead and scroll down here to my AI section, and we're going to take a look at new face data. And I'm actually going to go through the process of doing with you guys, of adding images right here as we go on a little bit here later on in the presentation. So one thing that I want to point out here is, well, what are these images right here that we're putting into these categories? So you can see I have my first category that says Jake. And I have my second category says Damiana. I was able to take this picture. Damiana is one of my co-workers on the STEM Education Works team. And so why is it that we're having to take these pictures first before we run our program? Well, the reason why is this. When we talk about things like image recognition or voice recognition for that matter, what we're really talking about, we use the broad term of AI pretty often. But at the end of the day, the more precise thing the more precise term to use to describe what something like the Dobot is doing is called, my gosh, it's escaped my head for a second. Machine learning, that's what it is. I forgot it for just a split second. So machine learning is basically this idea. You have an algorithm, and what you need to do is, before that algorithm can be used to produce intelligible results, you need to feed it a lot of data. So a really good example is, some of you guys might have used ChatGTP on the internet before, or maybe you use some AI software that produces an image when you say, you type in keywords like dog sitting in a field, and it produces an image for you. Well, the thing is, the way machine learning works is that the algorithm can't just produce those results for you. It can't just recognize things right off the bat. You have to feed it a lot of data over and over and over again, and that's how the algorithm is able to learn and recognize one thing versus another, or in more complex cases of AI situations, to develop maybe to write a program for you in Python. So you have to give a computer many examples for it to successfully pull off this machine learning process. And in this case, the data that I'm feeding to my Dobot, very simple. It's a picture of me, and it's a picture of somebody else. And so let me go ahead, let me test that data. And what I'm going to do is, I'm actually going to flip up my camera. You should be able to see me on that Dobot camera now. And I'm going to go ahead and click Training Model. I'm just going to sit here and smile for the camera. Hello. Oh, and as you can see, the algorithm that the Dobot is using, it is 98.7% sure that it's me rather than Damiana. And that's a very simplified form of how machine learning works. So let's go ahead, let's leave my camera right there where it is. I'm going to click Finish, and I'm going to go ahead and run my program. So I'm going to lean in here. Hello, Dobot. How are you doing? It's counting down from 3.
Hello, Jake.
Ah, very good, Dobot. It said, hello, Jake, instead of saying, who are you? So it recognized my face. So what's a really cool thing you could do in the classroom with this? You could have your students develop a program, and then you could have it so that the password for making that program run is that the Dobot's camera needs to see your face. And then let's say the student passes that program over to another student, and it sees their face. It's going to say, oh, who are you? I'm not going to run the rest of the program. So this is a good example of facial recognition technology that we see in so much of the technology around us nowadays. So let me go ahead. I'm going to reposition my Dobot here. So that was a cool, quick little look at the facial recognition capabilities of the Dobot. Now, we're going to switch gears again, and we're going to go back to my PowerPoint show. One moment. There we go. Perfect. Let me go ahead and move this guy real quick. There we go. Awesome. So next is picture recognition. And now it's where it's getting really, really cool. Because now instead of just giving it two pieces of data, so an image of me and an image of somebody else, now things are getting a little tricky. And what we're going to actually be doing is we're going to be using these little rubber models here that we have. One says water on it, one says coffee. So we got water right here, we have coffee right here, milk right here, and cola right there. And I'll go ahead and I'll place those on the mat here so you guys will be able to take a look at what that looks like. So these little items, as well as some of these fruits and veggies that we see here, these come with the Dobot AI teaching kit. There's actually a kit that comes with a lot of these items that are really useful for to pair up with the AI image recognition capabilities of the Dobot. Basically, what you want to look for in the items that you're using is you want to make sure that there's slightly different shapes, different colors. You want to make sure that they are different enough from each other so the Dobot can easily tell them apart. But you also want them to be not so detailed that you have to take a million different pictures for it to recognize each item. So a nice little kind of in-between value like these guys here. So I'm going to go ahead, place those off there for the moment. And let me go ahead. Yep, there we go. Back to our slides there. So this is an example of what it will look like as you are calibrating your Dobot, feeding it data so it can make those machine learning cool moves that we talked about. But we'll actually go through this process manually here in just a second. And of course, as we are classifying this data, what it should be able to do at the end of the day is we should be able to put one of these 4 items in front of the Dobot's camera, and the Dobot should be able to tell them apart. So let's take a look at what our code is going to look like before we dive in and do it actually, live. So first things first, we have 2 variables in our code here. So we have the item that the Dobot sees, and we have a status variable. So we're going to clear those out first things first. And then what we're going to do is, like we did before, we're going to have the camera take a picture after a 3-second countdown. We are going to set our variable equal to the tag of the picture that it took. So for instance, let's say I put the cola in front of the camera there. Then the variable item should be assigned to a string of letters that spell out COLA, the tag of the particular pictures that we took of it. And then we are going to be performing a test to see if it really truly was able to recognize the difference between these different objects. And we're going to say, does the string item, that variable item, does it contain the word cola? And if yes, then it's going to say yes. Our status variable is going to change to the word yes. And if not, it's going to say no. So let's go ahead. We're going to switch gears again, and we're going to take a look at our Dobot Lab screen. Can you see the Dobot Lab screen okay? Awesome. So we're going to go to Open. This is another really cool feature with Dobot Lab is you can save all these different projects so you don't have to recreate your complex, cool programs. And we want picture recognition. So it's going to take a second for it to load. We're going to switch to Dobot Magician Lite mode. We're going to connect. Home, we're already homed. We are good to go. So let me go ahead and let me zoom in a little bit. This is that code that we just took a look at. And so, again, We cannot actually run this code right now because we actually need to feed data into the program so it can tell the difference between cola, milk, water, and coffee. So in order to do that, before we actually click this green flag to run our program, we're actually going to go to the AI tab here. And we are going to go up here to edit classification data. And so I have my camera selected there. Notice that little part at the bottom there, that is the tip of this of the gripper. So I'm actually going to rotate my gripper slightly just to get that out of frame. There we go. And so you'll notice that right now we're on color cutting mode. We want picture recognition mode. So as you can see, I was fiddling around with this earlier, but you know what? I'm going to delete all that data because I'm going to start from scratch and show you guys how to do this. So we have 4 items. We have milk, we have cola, we have water, and we have coffee. Oh, I missed an E there. I don't drink coffee, so that's why I misspelled the word coffee. So first things first, let's go ahead and place our milk right there. And adding this data, giving the program data so it can tell apart these different objects, is as simple as clicking that plus sign. And notice that I want to reposition it each time. And that is going to give the Dobot a series of images looking at these objects, but in slightly different positions. And so that means that I don't have to be extremely precise with how I place the object on my wood mat here when I go to test it. So I'm going to do that again. And the process is going to be very similar for my cola. So I'm going to go ahead and click that guy. I'm going to reposition it. And notice I'm laying these guys flat right now just to kind of make it easier for the Dobot to recognize it. But of course, one thing I could do is I could place my cola vertically. So in case someone placed it there, the Dobot would be able to recognize that as well. But I'm going to make it a little easier for our Dobot just by having it kind of in the same position each time. Okay, now let's do our water. Going to place our water there. Notice that it really doesn't matter if the word water is facing the camera. You want to have all different angles that you're looking at. So the program has the most data possible to reference when it runs the program. And let's do it again. Again, we're keeping things simple and laying them on their sides. And lastly, we have our coffee. I think I might be the only person in the world who has ever gotten through grad school by never drinking coffee. That's a thing that grad students are big on, but just never really liked the flavor. Cool. So now, before we actually run the program, we can click this guy here, and we can run a training model. And basically, this is going to test if the data that we fed to our program is sufficient enough to tell these objects apart. So as we can see, it is 97%, 99 point, oh, it's fluctuating a little bit, 97-ish% sure that that's coffee. And what do you know? That is correct. That is coffee. Now, let's put our water down and let's give it a second. 99% sure that it's water. And let's do the same with milk. 99% sure that it is milk. And lastly, we have some cola. And there we go, 97% sure. Now, let's actually do this. Let's test that and see what happens. Notice that it kind of switched there. It's because we didn't feed it any of the images of it sitting upright. So if you want it to be able to recognize this, then we have to feed more of those images into that previous page that we were looking at. But of course, if it's on its side like that, it is sure that it's cola. Okay, so now we can go to finish. And now we can go ahead and let's see. Oh, eeny, meeny, miny, mo. I'm going to pick milk. And let's see if our program is able to successfully detect that it is milk. So we're doing the countdown. 3, 2, 1. And our result is milk. And of course, this makes sense. Our item says milk. And our status says no because it's not cola. So now let's switch it up a little bit. And now let's put the cola down and see what it does. So I'm going to close out of here and I'm going to run my program again. 3, 2, 1. And it does indeed recognize it as cola. My item variable right here says cola, and of course my status says cola. My logic gate here causes the status variable to say yes. So it's working just fine. And so next we're actually going to pump it up a notch. I think that's the Emerald saying. I'm not a very good cook, so I don't want to use that. So now we're going to actually switch over to shape recognition. And there's a really cool reason why I'm going to switch to shape recognition. And part of it has to do with the fact that as it's looking at an image, it can only recognize one image at a time. So for instance, if I have milk here and water here, and I'm still using picture recognition, let's go ahead, let's run our program and see what it does. And of course, it says water, because in this mode, it can only detect one thing at a time. And the next mode, it's going to be able to detect all 4 different categories at the same time, which is really cool. So that's that. I'm going to switch back to my slideshow. Here we go. Beautiful. Okay, so now I'm going to go over here. All right, cool. So now we're going to do shape recognition. So now instead of taking a picture, it's actually just going to kind of draw an outline of the shape of the object. So what this means is with picture recognition is going to be more accurate because it's not just looking at the shape of your object, it's looking at everything on the inside too. So that's the benefit of using image recognition, specifically picture recognition. But with shape recognition, it's a little less accurate, but you can detect multiple objects at once. So as we're setting up our calibration data here and feeding a bunch of data in the form of pictures to these different categories, coffee, cola, milk, water, what it can do is it will be able to differentiate between those different objects. Not only that, but count how many objects are in the frame at one time. So let's take a quick look at what that code is going to look like. So we have 3 variables in this case. We have our counter, which counts the number of objects in the field of view of the Dobot. We have our I, which is an index, which we're going to be using down at the loop that we have at the bottom of our code there. And we are also going to have a list listing all of the items that are shown in the workspace there. So we're clearing all 3 of those variables at the beginning. Then we are going to have our camera count down to 3 and then take a picture. And then we are going to use the block on the bottom there. We're going to use the shape cutting picture. We're going to take a look at the picture and we're going to recognize each individual object in our field of view. So then we're going to set our counter to the total number of items that are in that image. And we're going to initialize the value of our index to 1 at the very beginning. And then we're going to run through this loop here. And notice this is a conditional loop. We're repeating until the value I is greater than counter. And what I'm going to do is I'm going to put 4 objects on there at first. So it's going to count 1, 2, 3, 4. And then once it hits 5, it's not going to go back through the loop again. And then within that loop, we are adding the tag of that particular object to our list. And then we are increasing I by 1. So let's go ahead and drop out of there. Let's go to our Dobot Lab page. I want to go to Present, Share Screen, and we're going to go back to Dobot Lab. We're going to open Shape Recognition. Beautiful. It's taking a second to load. There we go. We're going to, again, just like we did before, we're going to switch to Magician Lite mode. We're going to connect our Dobot. home our Dobot, and we are good to go. And now we are going to feed it some more information, just like we did last time. So with the picture recognition mode, we needed to give it more images. Now we need to give it even more images so it can differentiate between the shapes of these objects. So to do that, we're going to go down here to AI, and we are going to go to the same edit classification data place right here, except instead of using picture recognition, we are using shape cutting. So as you can see, I already have some items in there, but I'm going to go ahead, I'm going to delete that data. I'm going to start from scratch so you guys can see exactly how it happens. So first off, milk. Second off, cola. Water. And coffee. And so the way we do this is we're going to go ahead and set our object there. Excuse me, one moment. And as you can see, it has drawn a box around that object. So I can see I have this box here highlighted. So as I click that, I can add that data to my tag that is milk. And again, it takes a second for it to recognize the shape and differentiate it from the background. I like using these kind of like wood or solid colored mats so the object really stands out. And I think 6 for each is going to be sufficient. So now we're switching modes here. Now we're going to take some pictures of our cola. And again, it's going to recognize that. It's also going to wait for the thing to stop rolling around before it takes the picture. Beautiful. All right. And of course, it's going to do that guy. And so now we're going to switch over to water. Now for water, I'm going to do a little trick. Earlier when I was playing around with this, I think my background here might be slightly too light. So as I'm placing my water down, instead of placing it like this, notice how the shape of the cola and the water are very similar. So I'm going to make it extra easy for my Dobot here. And I'm going to just take a look at the top of my water. So I'm placing it vertically and just moving it around, getting it in different, angles, shadows, making sure that my Dobot can recognize this when we run our program. So we got this guy here. And you can absolutely lay the water down like this and differentiate it from the cola. You just have to take a lot more pictures, and just for the sake of time, we're just keeping it simple this time. So the Dobot has it a little easier. So we have our coffee. Give it a second. So we're going to select that image. Then again, we're going to pivot. And we are going to take that image, just a few more. There we go, and just a couple more. So you notice that it's starting to think that the top of the coffee cup is different from the bottom of it. And that's normal right there. That angle right there, so we can get the full image, is the best way to do it. So you may have to reposition it a little bit for the camera to clearly see it. So we're going to go ahead and do our training model. But first, we're going to make this pretty complicated for our Dobot. I'm going to have all 4 of those objects there, and we're going to see what happens when you go to the training model. So it's taking a second to load. And so we can select this segmentation test. And as you will see, see, this is a good example where basically the cola is indicated by yellow. So that's correct. The water is indicated by blue, and the red is supposed to indicate milk. But notice that these, it's looking at them like they're the same. So in fact, I'm going to actually reposition these a little bit. I'm going to make it a little easier for the Dobot to differentiate between them. So I'm going to go back here, go back to training model. It's going to take a second to load. Beautiful. Now it worked. So there's kind of two different ways you can approach that when that happens. You can either kind of tweak the angle of your objects or take more pictures, because the more pictures you're taking, the easier it is going to be for the Dobot to differentiate these different items. So as we can see here, red is milk, check, that's correct. Cola is yellow, check. Water is blue, check, and coffee is green. We're good. So now, since we've fed our data to our computer, let's go ahead and click the go button. That's counting down. And so right off the bat, we have the counter. And so notice the counter actually, again, this is a situation where taking more pictures would be helpful, but just for the sake of time, notice that it was indicating, it was thinking that this part of the coffee and the lid were two different objects. So it thinks that there's 5 objects when there's really 4. But as you can see, it listed all of them off. We have this object here, this image here, it's recognizing it as milk. We have this image here, it recognizes it as cola. This one recognizes it as coffee. Again, it's just kind of doubled up on there. I think this one thought it was milk because of the white part of it. And this one successfully indicated that it's water. And so as you can see, look at our results over here. Our counter technically should say 4. And then our I is our index that we use to go through our loop. And then in our list, we have milk, cola, coffee, and water. So it was able to detect all of them. And so now, let me go ahead and stop sharing and let me switch over back to our screen here. Okay. And I'm going to go back to from current slide. Go down here, and here we go. So that is the slide we already saw. And next, we're going to go over color recognition. So again, what we've looked at already with the image recognition, we've looked at picture recognition, where it looks at the whole scan of the object. We've looked at shape recognition, where it just looks at the outline of it. And now we're going to look at the different colored blocks here and differentiate our objects that way. So as we are adding images here, notice these images are pretty much all the same because you're looking at the top of a cube, and the top of the cube is pretty much going to look the same, but it is a good idea to kind of move them around a little bit so you get areas where there's more light, less light, so it can tell that, okay, this is red no matter what position it's in. So as you can see here, we're going to go through the same segmentation test, and it's going to be able to detect the different colors. Our code is going to look a little something like this. It's very similar to the previous one we did with the shape cutting. We're going to have a counter, an index, and a list, and we're going to clear those all at the beginning. We're going to do the exact same thing that we did before, and we're going to take a picture and then differentiate between the items in our picture. We are going to set our counter equal to the total number of items that that the Dobot can see in its viewing range. We're going to initialize our I value to 1, and then we're going to go through the exact same process, but instead of adding shapes to our list, we're going to add colors. And so let's go ahead and take a look at our Dobot lab screen. I'm going to stop sharing, go to present. And it's just going to take a second for it to load. Oh, I kind of need to open up the correct thing first. Let's see, we want color recognition. So again, we're going to go here. There we go. We are going to connect our Dobot. We're going to set it so that it is homed. And we are going to go through this exact same process. We're going to feed it data so it can differentiate between these different colors here. So again, in order to do that, we're going to click our AI tab. We're going to scroll down a little bit, go to our classification data, and we're going to select color cutting. And as you can see, I've already added in the colors here for you. Basically, all I did is, just like I did before, I took various images of these blocks in different locations. And as you can see, here are 3 different views of the red block, 3 different views of the green block, and 3 different views of the blue block. And so let's go ahead and use our training model and see how well it does. So we're going to do a segmentation test, and voila, got it right the first time. So of course, red is highlighted with a red box, check. Green is highlighted with yellow, close enough. But yes, yellow corresponds to the green block. I wish it were green, that'd be a 1-to-1 match. And then the blue highlight is indicated to show the blue block. Awesome, we're good to go. That means that we have given our program enough data to work with. We're going to click finish, and we are going to run our program. And this program is going to work in very similar ways that the shape cutting program did previously. We have our counter equaling 3 blocks. Like the count from Sesame Street. Yeah, it's funny. So 3 blocks. Our index value went to 4. That's because it went to 4 and it stopped running once that I value 4 was greater than 3. And we have our list, green, red, and blue. So the Dobot was able to detect the different colors perfectly the first time. So let's put that off to the side there. We're going to finish up our presentation today by looking at a couple more examples of what the Dobot AI system can do. I want to go ahead and present. I'm going to go back to my slideshow. Okay, and I'm going to minimize. There we go. So it can also do text recognition. Text recognition would be used to detect the text that is on these blocks that you see right here. These little blocks also come with the Dobot AI teaching kit. And so I'll just run through you real quick what that would look like. The program that we would use to run that, first off, we would want to set our language to English. We want to clear our variables. Notice we have items here and status. We're going to tell our camera to count down, to take a picture on the countdown to 3. We are setting our item equal to the words that we're seeing in the picture. And then we're going to ask ourselves, does this variable called items, does it contain the word coffee? And if yes, it's going to say, the status is going to say yes. And if no, the status variable is going to say no. And so with that, that ends our presentation for today. I hope you guys enjoyed. This is some of the really, really cool things you can do with the Dobot Magician Lite in terms of its AI capabilities. Something that we didn't quite have time for today is you can also make it so that the camera can detect the X and Y coordinate of a particular object here. So I can set my object right here. The camera will be able to tell what that object is, and then the claw can move down and pick it up wherever it's located in your viewing area, which is pretty cool. We are kind of interested in developing some curriculum around this in the future because it's such a cool feature, incorporating AI along with the capabilities of the Dobot Magician Lite. Of course, the Dobot Magician Lite also features not only a gripper end effector, but also a pin end effector, as well as a suction cup end effector. So yeah, if we have any questions in the chat, I'd love to answer some of those. So let me go over here and check. Let's see. If anybody has any questions, let me know and I'd be glad to answer. Okay, can you post the comment and contact information in the chat? Um, yeah, so I can send you guys a follow-up email as well that will feature this the slideshow that I used today. Uh, well, I'll go ahead and I'll include that in the email for the follow-up. But just in case you guys wanted it now, my email is located on there. Christy S, thank you for typing that out. My email is jacob.rourke@stemeducationworks.com. Cool, cool. Well, if nobody has any other questions, we'll bring the presentation to a close today. Um, Feel free to contact any of us at STEM Education Works if you guys are interested in implementing the Dobot Magician Lite or any of our other products in your classroom. And have a nice day.